and then your outcome is a bunch of damn ones. Well, maybe these guys got twos. Maybe they kind of stayed with it, but these guys are ones mostly, right? All right. So that's all you really need, right? This is kind of what I was demonstrating earlier.
Yeah.
Is kind of you do a one sample T. You test all those variables. Well, no, let's do population, and let's say we want to test the difference of population with this Clark Middle.
Okay.
All right, so that's all you got to do is specify an alpha level, and then the number.
Mm-hmm.
It's going to run that analysis. See, that's your p-value. It's going to say the mean of all those schools was significantly different from what you put in.
From the 700.
Yep. And then let's do another one, because we're going to have to do one of these for every variable.
Mm-hmm.
Let's see about OSS. Let's say the mean of OSS was, I can't remember. Hold on, let's go back over.
But you're just comparing it to the number from the Clark Middle.
Right.
Mm-hmm.
Let's say the Clark Middle OSS for last year was 50.
Right. Mm-hmm.
And these are like 100 to 50. Oh no, let's do 75. It's right in the middle between 50, right?
Okay.
You see, it's not significant.
Mm-hmm.
I mean, you notice how I'm setting these tests up to lose, right?
Mm-hmm.
I'm essentially saying 100 to 50 is 75 different. The answer is always going to be no, right?
Mm-hmm.
Because 75 is in between 100.
Right.
Does that make sense? I know this is how I do this math in my head.
Yeah.
I kind of definitively know. Okay.
You already know the answer, basically, or.
Yeah, I mean, because I created this data set.
Right.
But not creating the data is what we want. So let's say we know Clark's RJ is 35.
Mm-hmm.
Bam. That's heavy.
Mm-hmm.
So remember, it only needs to be a 2.
Right.
See how this one wasn't 2.
Mm-hmm.
So you would say, wow, this is very significant. Very heavy. Clark kicked the shit out of all 7 of these schools.
Mm-hmm.
RJ program. And then last, what you'd want to do is you couldn't use this for outcome.
Okay.
Because this is categorical.
Mm-hmm.
So this is where you would do a regression.
Mm-hmm.
And you'd say, do these things predict that?
Mm-hmm.
Right? Do these 3 values
predict outcomes?
Right.
It's checking that they're. Oh, go ahead.
No, you're good.
It's just measuring the correlation somehow?
Yeah. It takes the Pearson product correlation of every value, which we call unstandardized coefficients. That's what remember those B values I was showing you?
Yeah.
But look, it's significant. The overall model is saying, yeah, those things do predict whether people stay in the RJ or not. Right? The higher the number, somewhere, hold on, let me find it. I'm blind. Here it is. Higher the number, the 24 is the difference. So essentially you say this is a mean square error. This is what he was trying to teach you on those slides, but I digress because it's a little late in the semester to be doing that. So
yeah.
It takes the t-value of every single one of those variables, negative. So it's saying RJ significantly predicted whether people stayed in the program or not. See what I'm saying?
Yeah, I think so, yeah.
Is this making sense?
Yeah. It's making enough sense that I can go forward and do it, I think. Does that make sense?
yeah. The goal here was to give you a crash course.
Exactly. Yeah. So I don't want to be spinning my wheels,
Yeah, and maybe when you get to this point, maybe when you've ran those 3 t-tests on your 3 variables, and remember, you don't want to do too freaking much.
Yeah. No, I'm trying to keep it simple. I want to keep it simple.
Evaluate because we know what you have. Evaluate population, evaluate OSS, and evaluate other programs.
Uh-huh.
And just call other programs RJ. Just for the sake of this class. Just for the sake of this freaking assignment, you know? And then I recommend you create a variable. Okay? And you can actually do this. Like, this is what I did with Hoger, because he, I'm not saying you struggle, but Hoger struggles with English. So I could be a damn tutor at Kennesaw. I could be a damn professor at this point. But let's say RJ greater than 13, right? Would be 1. Less than 12 would be a 2. That's how you create your variable.
Okay.
And then when you do your what you'd have to do is you'd have to take the average. But I'm saying this is the average of this is 13, so that's why that number. And I did that in my head too, by the way. So
right.
I'm working fast here. So you'd say I created an outcome variable based on the number of other programs. Like, this is how I would write it.
Yeah.
Each middle school, I think that's one word or 2 words.
It's
Each
2
middle
words.
School,
yeah.
If the school had greater than 13 participants in other programs, I included them as 1, etc. If the school had less than 12, I made them a no, or 2. Right?
Now, is this because you're testing just to an effect, basically?
Yeah, exactly. It's that predictor. Let me go back here. Variable out. So you're testing how well these variables, population, OSS, and RJ, predicted the outcome of whether they kept or whether they threw the program away.
Okay.
So I would say 1, one was they didn't need it. They realized we're not even using this shit. Just throwing everybody in OSS. So we don't need RJ. So 1. But these people were like, hey, you know what? This ain't so bad. I kind of like this program because it helps these 13 kids. Helps this 10 kids down here. So we're going to pick yes. We're going to pick 2. We're going to keep the program. Get what I'm saying?
And that part there is just you just made that up, the randomness of, because the actual thing is, as far as
I didn't make it up. This is how data is actually recorded in the real world.
No, I get that, but what I'm saying is, like, I know the only place they're doing the RJ is at Clark Middle,
Well, you'd have to make it up for the 7 schools.
That's what I'm talking about.
Just make it up. That's what I didn't make it up randomly.
No.
I did this. This is the key. You want to create a criterion. This is what we call.
Yeah.
Right? Yeah, it's a criterion variable. Because you're saying you're specifying a specific range. Right? That would be 13. And that would be a yes, and below 13 would be a no. But you don't have to use 13.
Right.
You got to look at the real data.
Okay.
So if it's like, it could be like 45. And Clark could be like 20. And then what would happen? You would have, so let's do a hypothetical here. Let's say 1, let's say 2. So I'm going to rerun this. Yeah. Because I punched these in there, and these were 1s, the model isn't good. This is what we call a regression model, right? It's a model summary, right? So it's saying, well, your predictor of RJ is significantly effing up. And remember, I didn't change any of these.
Right.
I changed just this one.
Uh-huh.
But it's so powerful of a change that it messed up the model really bad. See?
Mm-hmm.
This should not negatively predict anything. It should be very positive like it was up here.
Mm-hmm.
So these things are just not good. They're not predictors. So you would say this is you would say none of these variables were significant predictors whether a school kept the RJ program or not.
Mm-hmm.
Based on what, right? Based on my criterion variable.
Right.
Does that make sense?
Yes. Mm-hmm.
So this is what I would say is custom, or you got to create it, because you're the expert. You're the RJ king, right?
Uh-huh.
I think you are.
Okay.
And I think when it comes down to it, you got to be the expert in creating what counts as a yes or a no, right? What is it going to take for all the schools in Georgia to say yes to RJ? That's what we want. We don't want kids getting thrown out of school and playing video games all day.
Right.
We want kids in restorative justice so they learn to correct their actions and their behaviors and their attitudes. Psychology supports that. The literature supports that. I mean, freaking Jean-Paul Lederach supports that.
Right on.
we got everybody supporting that. So we gotta, and by the way, Jean-Paul Lederach's a psychologist, right? So we gotta support what the research says through our outcome variable, through our predictive test analysis. That's kind of that would be what I would call the tagline or the bottom line. You want to give them the bottom line is that schools that kept these programs did better, or they didn't.
Uh-huh. Right.
That's what we're trying to test.
Okay.
Cool?
Yeah, all right, man. Thank you. Yeah.
Yeah, no problem. It's my pleasure, honestly. I like teaching, and
yeah.
I'm going to do my best to make it work.
Amen.
Just figure out how to